All right, the question here is to show that the triangle is a right triangle using the converse of the Pythagorean theorem. Well, that's actually, there is no converse of the Pythagorean theorem. The Pythagorean theorem is that leg squared plus leg squared is equal to hypotenuse squared if it's a right triangle, and vice versa. If leg squared plus leg squared equals hypotenuse squared, it is a right triangle. It's what we call a tautology. And so we want to use the second part, which we usually don't use, which is being referred to here as a converse. But it's a tautology, so we're using the one that we're not as familiar with, that if the leg squared plus leg squared is hypotenuse squared, then it's going to be a right triangle. It's 2 in 1 statements. So let's draw this. This is my clunky drawing. I take those 3 points, they form the vertices. I've kind of drawn it badly, but I can see which one's the hypotenuse. It's B to C, and the legs are A to C and B to C. A to B, sorry. So there's my leg, and hypotenuse. So what I need to do first is I need to calculate the length of this leg and the length of that leg. Well, that's distance formula. So I'm going to use the distance formula to find the length of the legs. So this is what is referred to as AB with a line through it. What that means is it's the length of AB. So how do I do that? I use distance formula. And let me pop the distance formula up here for you. It's x1 minus y1 plus x2 minus y2, and each one of those are squared. And so I put little labels underneath my x1, y1, and x2, y2. Just helps me not make a mistake. And if you work with me very closely, you know that I make a lot of mistakes. So it turns out that after I do the arithmetic, I get a square root of 41. So it looks like Webasine is correct. Next, I want to find AC. So I do the same thing, except now my x2, y2 is the C's, the C coordinates. And so I run it through the distance formula, and I happen to get square root of 41 again. And then I want BC. So what do? Well, my x1, y1 is now B, and the coordinates of B. And I run it through the distance formula again, and I get square root of 82. And what's wanted here on the next thing? Well, this is leg, and this is leg. So what is leg squared plus leg squared? Well, leg squared, it's without the hat. The radical comes off because when I square it, I don't have a radical anymore. Plus leg squared, I get another 41, and it equals 82. And that does turn out to be the hypotenuse squared because I see the hypotenuse was square root of 82, and the hypotenuse squared is 82. So it works. I thought this was a very nice problem. It's my kind of problem. I like it.